So now look at the tangent to a circle from a point that is not on the circle. So if we have a look here, we have a circle. P is a point not on the circle, and what we'll be asked to do is find the equation of these two tangents. In this example, we're asked to find the equations of the tangents to the circle x squared plus y squared minus 4x plus 6y minus 3 equals 0 from the point 6, 7. And once again, we'll start with a in this diagram, we can see the circle x squared plus y squared minus 4x plus 6y minus 3 equals 0. So that's a circle with a centre 2 minus 3. We've the point 6, 7, and we want to find the equation of the tangents to the circle from that point. So what we have to find is the equation of the lines through the point 6, 7, where the perpendicular distance from the centre to each of these lines is equal to the radius. So first of all, we will look at a line through the point 6, 7. Now we know the equation of any line is y minus y1 equals m times x minus x1. So we have y minus 7 is equal to m times x minus 6. Tidying that up, y minus 7 is equal to mx minus 6m, or we can just write mx minus y plus 7 minus 6m equals 0. So that's the equation of the lines we're looking for. But of course we know that the perpendicular distance from the centre to the line has to be equal to the radius. Now the centre of the circle we can see clearly is 2 minus 3, and we can work out the radius using the square root of g squared plus f squared minus c. So we get the radius to be the square root of 4 plus 9 plus 3, and that's the square root of 16, which is equal to 4. So the radius is 4. So the distance from 2 minus 3 to this line here must be equal to 4, and we'll have a look at that now. So from 2 minus 3 to the line mx minus y plus 7 minus 6m equals 0. The distance from the point to the line is 4. Plugging that into our perpendicular distance formula, we have m times 2 plus minus 1 times minus 3 plus 7 minus 6m, the absolute value of that, over the square root of m squared plus minus 1 squared, and all of that must equal to 4. So we just tidy up again, and we get on the top line the absolute value of 2m plus 3 plus 7 minus 6m over the square root of m squared plus 1 equals 4. And I will multiply both sides by the square root of m squared plus 1, which gives us the absolute value of 2m plus 3 plus 7 minus 6m equals 4 times the square root of m squared plus 1. On the left hand side, if we tidy up, we get the absolute value of 10 minus 4m, and that's equal to 4 times the square root of m squared plus 1. And we recall from before that if we have an absolute value, it always has to be positive. So if that always is positive, how do we know this here is going to be positive? We will just, the only way we know something is positive is by squaring it. So we will now square both sides. So we have 10 minus 4m to be squared, and on the right hand side, if we square, we get 4 squared is 16, and if we square the square root of m squared plus 1, of course, we get m squared plus 1. Multiplying that out, we will have 100 minus 80m plus 16m squared is equal to 16m squared plus 16. And we just tidy up. And that gives us 100 minus 80m is equal to 16 minus 80m is equal to minus 84. Dividing across by minus 80 gives us m equals 84 over 80, or m equals 21 over 20. So we now have the slope of one of the tangents. So this tells us that the tangent, which we wrote down already as mx minus y plus 7 minus 6m equals 0. We can just sub in for m. So we have 21 over 20x minus y plus 7 minus 6 times 21 over 20 equals 0. Multiplying across by 20 to get rid of the fractions, we get 21x minus 20y plus 140 minus 126 equals 0. And we just tidy that up and we get 21x minus 20y plus 14 equals 0. Now that is the equation of one of our tangents, but we still have to find the equation of our second tangent.